So in I, we have the limit as x goes to 1 of sine x minus 1 over x minus 1 times ln x. So if we take a look at those two parts separately, the sine part and the log part, we can deal with those separately as limits. And as we let x go to 1, the sine x minus 1 over x minus 1 becomes sine 0 over 0. Well, that's an identity, and we can determine that to be a value of 1. Okay, and we have that from an identity. When we look at the ln part as x approaches 1, well, if they take a look at the log graph, so this blue graph is the log graph. As it approaches 1 from both sides, it's really just going to be equal to 0. In fact, we can just plug in x is 1, and we get log is 0, and so the limit is going to be equal to 0 for that whole piece. So sine 1 minus x over 1 minus x times ln x as we go to 1 is going to be equal to 0. Now, this one here is pretty much the same thing. However, because we're going to 0, in this case, the green part of the limit we can just plug in. So we're just going to plug in x is 0, so we get sine of negative 1 over negative 1. And we can evaluate that, so that's some value that we can evaluate. But when we plug in limit as x goes to 0 from the positive side of log x, well, we have to make sure that we're clear that what's happening here. So we know that it's going from the positive side here. So it's going this way. And so we're going down to negative infinity. So that value is going to be negative infinity. So then we can evaluate this. This should be equal to negative infinity, but we have to be a little bit careful of the signs here because sine of negative 1, well, sine of negative 1, I'm just going to draw a quick little diagram here. Sine of negative 1 is in quadrant 4. Okay, so negative 1 angle is not at negative 1.57, which is 90 degrees. So that means that the sine value is negative. So in the numerator here, we have negative. So what I'm doing here is I'm just checking the signs. In the denominator, it's going to be negative 1, so it's negative here. And then we have negative infinity. So this is going to be, the limit will be negative infinity. Okay, so that is the final limit for this problem. As we go to 0 from the positive side, that the limit of that expression is going to go to negative infinity. So it should dive down to negative infinity and along an asymptote. Okay, and again, we can check this on our graph.